Hey, this is Mr. Aiden. This is Integration and the Accumulation of Change, Unit 6. And last video we were doing the left and right hand Riemann sums. This video we're going to be doing midpoint and trapezoidal Riemann sums, just a different way to look at the area under a curve. So let's get to the midpoint Riemann sums. So what is the midpoint? The midpoint is the middle point. So remember, if we were doing the left-handed Riemann sums, we would start. Let's say we were starting on the left side and we would do a rectangle. We would then go to the next left-handed point we did and we'd do a rectangle. Now remember, we could split this up into smaller sizes. We could do a left-handed rectangle point, we could do a left-handed rectangular point, left-handed rectangular point, and left-handed, and so on and so forth, to get more and more close to the area. Now when we did the right-handed, we would come to the right-hand side. But now we're going to do what's called the midpoint Riemann sums. So we're going to take the middle point. That's what the midpoint is, the middle point. So let's say we're going to use, we're going to go from -1 all the way to 2. We're going to try to find the area under this curve using midpoint Riemann sums. We're going to take the middle point, which, what's the middle point right here, is -0.5. And we're going to put that into our function, f of -0.5. So let's say we have -0.5, and we are going to square that guy, and we're going to add 1. We end up getting 5/4. And so you can see right here at 5/4, that is my middle point. So that is the rectangle that I'm going to have right here. So my height is at 5/4. My width is 1 unit long. Now, then we're going to take this middle point between 0 and 1, which is +0.5, and we get the same thing. f of 0.5 is equal to 5/4. And so we have another rectangle right here. Now, what is our middle point between 1 and 2? Is 1.5. And so we have to take f of 1.5. So we plug that in our function. 1.5 squared plus 1 ends up becoming 3.25. 3.25 right up here. 3.25. And that is the rectangle we're going to have to take the area. Now let's think of the area here. We're starting at 5/4, or 1.25, times a width of 1, plus 5/4, that's the height of the next one, times 1, plus 3.25 times a width of 1. And so I add up all of these. 5/4 plus 5/4 plus 3.25, and I end up getting an area of 5.75, and that is the area under all of these midpoint Riemann sums. Now, of course, you can see this midpoint Riemann sum, we're not taking into account that area and this area and this area, but we are taking into account this area and this area and this area. So this midpoint Riemann sum might be a little bit closer to the exact area underneath this curve. So how are we taking the midpoint Riemann sums? Well, you're taking a look at the width of how many rectangles you want. Here we had 3 Riemann sums of equal length. Now, if we had 6 Riemann sums, we would have to take a look at this midpoint right here, which would be -0.75, and we would plug that in our function, so on and so forth. And that would give us, the more rectangles we have, the better and better our approximation of our area. So let's now take a look at trapezoidal Riemann sums. So what the heck is a trapezoid? So remember all the way back to our geometry. Our area of a trapezoid is this length A and this length B added up together, divided by 2, so kind of the average between those, times the height. Now we're going to kind of flip this way and think of the height as your delta x. That is going to be equal to the height. So we're kind of flipping this trapezoid. And then we're going to take a look at our y1 and our y2 as our sides A and B. And so it's, for Riemann sums, it's going to be y1 plus y2 divided by 2 times your delta x. And that is going to give you the area of this little Riemann sum right here. So let's do an example problem. So here we're going to take our Riemann sums, and let's say we want trapezoid Riemann sums, and we want three equal trapezoids that we're going to be using. So we're going to go from 0 to 3 for three equal trapezoids. So let's take a look at the first trapezoid here. We have our y1, which is 7 units high. We have our y2, which is 3 units high, and our delta x is 1 unit. So what is our Riemann sum? It's going to be 7 plus 3 divided by 2 times the width of 1. And now we're going to take a look at our second trapezoid that we're using here. The second trapezoid. We have our y1 is 3 units high, plus our y2 is 1 unit high, divided by 2 times 1 unit in this length this way. And then our last trapezoid is right here, okay? And our y1 is 1 unit high plus 1 unit high plus here we are 2 units high where we're ending, divided by 2 times the width of 1. And so now we can add all of these up. We got 7 plus 3, that's 10 divided by 2, that's 5 times 1, plus 3 plus 1, that's 4. 4 divided by 2 is 2 times 1. 1 plus 2 is 3, divided by 2 is 3 halves. And so what do I have? We have 5 plus 2 plus 3 halves, and we end up getting 8.5 is my area using this Riemann sum. So this is going to be, trapezoids are really good because you can say, especially with curves, it's doing a good amount of our areas. It's taking a lot of these areas into effect when I take these Riemann sums, and the area underneath is 8.5. It's going to be a lot closer to the true area underneath that. And so you can see how we have both our midpoint and our trapezoidal Riemann sums. So let me give you an example of, this is from the 2006 AP Calculus exam. We're trying to find the midpoint Riemann sum using only three subintervals of equal length. We're going from 10 to 70. So we're going from 10 to 70. So let's think about what three equal subintervals would be. That's a difference of 60. 60 divided by 3 is 20. So you can see how we're going to take that. We're going to take that. And we're going to take that. Between 10 and 30, between 30 and 50, between 50 and 70. And we're using the midpoint. So how in the world would we do the midpoint for this? Well, what's the middle between 10 and 30? Well, that's 22. That's 20 and 22. So what do we have here is the middle point is 22. That's the middle height. Times the delta x, which is 20 units difference, plus the middle between 30 and 50 is right here, that's 35. What's our delta x between 30 and 50? That is 20 units. And then what's the middle between 50 and 70? Well, that is going to be 60, which ends up giving you a height of 44. And the difference is 20. So we're doing our midpoint Riemann sums. Remember the midpoint Riemann sums, if you kind of graph this out, the middle between your 10 and 30 point is right at 20, and that was 22 units high, and so we were doing a little rectangle there. 22 units high. This is 20 units in width because of from 10 to 30. And so we're going to add this up on our calculator. 20 times 22 plus 35 times 20 plus 44 times 20, and that ends up giving me the crazy year of 2020. And so that is your area using the midpoint Riemann sums. That's the 2006 AP Calculus exam from a table. Here's a 2011 AP exam, and this is an example of, we're going to use a trapezoidal sum with 4 subintervals, and we're going from 0 to 10. And so we're going to use 4 subintervals. We're going to use a trapezoid. Now remember, what is a trapezoid? Trapezoid is the height of 1 plus the height of the second, so 66 plus 60 divided by 2 times your width. Your width is from 0 to 2. Then we're doing another trapezoid. We're doing 60 plus 52 divided by 2, the average, and what's the difference there is 3. We don't have equal subintervals this time. Then we're going from 52 and 44. Those are our two heights divided by 2. And we're going from 5 to 9. That's 4 units in difference. And then we have 44 and 43, the average there. And we're going from 9 to 10, which is 1 unit in difference. And so when we add this up, we're going to get 66 plus 60 divided by 2. That's 63 times 2. Plus, we have 60 plus 52 divided by 2. That's 56 times 3. Plus 52 and 44 divided by 2. That's 48 times 4. Plus 44 plus 43 divided by 2. That's 43.5. Oh, sorry, I did that a little bit wrong. Let me add that up to 43.5. 43.5 times 1. Now I'm going to add up all of these. 63 times 2 plus 56 times 3 plus 48 times 4 plus 43.5 times 1. And we get 529.5. And that is using the area, using 4 subintervals, using a trapezoidal Riemann sum. Remember, trapezoids, you're using height 1 and height 2. Divide by 2, the area average, times your change in your x. And that's midpoint and trapezoidal Riemann sums. Hope that made sense. Now we know how to do left-handed, right-handed, midpoint, and trapezoidal. Have a good day.